Hello everyone, this is Mr. Jackson, and today we're going to be continuing our Concept 1 discussion on the skeletal system by looking into how bones can be classified, as well as how bones are structured at both the tissue level and the organ level. So let's get right into it. So bones can be classified in two ways, based on their location or their shape. Okay, so if we're classifying bones by their location, remember this is going to fall into either the axial skeleton, which includes your skull, your vertebrae, and your rib cage, or your appendicular skeleton, which involves your shoulder girdle, your pelvic girdle, and then the bones of your arms and legs. Okay, so there's location and then there's shape. And off of the shape, remember those three words that I'm going to keep going back to: form dictates function. The way that a bone is shaped is very much intentionally designed by generations and generations, millions of years of evolution. There are four main types of bone shapes that we want to be able to recognize and differentiate. Those are long bones, which you can see over here to the right. Okay, you can just tell that they are longer. Short bones, again, shorter. We'll go into each one of these in a little bit more detail. You have flat bones, going to be relatively flat overall. And then you have irregular bones, which don't really fall neatly into the other three categories. They have very unique shapes. And so let's go ahead and get a little bit more into detail with those. So with long bones, these are going to be bones that are longer than they are wide. They tend to have a long shaft. This is right here. This portion of the bone would be called the shaft, and with either end being a bit wider. Okay, mostly located in your limbs, so your arms or legs. That's where you'll find the most of these, and they are really good as levers to help in movement. In our part 2, or our concept 2 of this unit, we'll be going all into movement and how your body uses lever systems. The shape of long bones makes them advantageous for creating a lot of force with a little bit of effort, and so we'll go into that a little more later. Some examples of where you would find these: in your arms, your hands, your legs, and your feet. We have some specific examples here. Most of these specific bones, you're going to have plenty of time to work with those in our station and lab activities. For the sake of lecture, we're just going to make sure that they're identified here for you. So we covered long bones. That implies that we're going to have some short bones. These are going to be more cube-shaped, so just as wide as they are long, providing support and stability with very little room for movement is key here. So you're going to primarily see these shorter bones in your wrists and ankles. They're going to be a lot more numerous. They're really, really good for support, very, very good for stability. There's a special type of short bone that we want to make sure that we identify called a sesamoid bone. Sesamoid because it tends to be shaped like a sesamoid seed or a sesame seed. These are embedded within tendons, and a perfect example would be your patella or your kneecap. You have flat bones. These are going to be thin and flat, as the name would imply. These often have a little bit of a curve to them. They have a very large surface area, and this is really good because with that large surface area, we can attach plenty of muscles. So these are really good for being the insertion or origin for a ton of different muscles. Your scapula or shoulder blades are a really good example. Your sternum, that breastbone in the middle of your chest. Your ribs are considered to be flat bones, and most of the bones of your skull are flat bones as well. And finally, you've got your irregular bones. This is basically just everything that didn't fall into a neat category: long, short, and then flat. These don't really fall into that neatly. These have very specialized form and function. Some examples here would be your hip bones and your vertebrae. Vertebrae are the key example here. So let's go ahead. So we've gone into classification again: axial or appendicular, whether it's at your axial skeleton or in your appendages. You've got your shape classifications, but now we want to do a little bit of a deep dive into how bone is structured. Okay, and despite all the variety in bone shape, most bones will have relatively the same internal structure, and that's going to include, as you can see in the image here, a dense, smooth layer of compact bone and that's going to be surrounding a more porous interior spongy bone tissue. Now we're going to break down what the physiology is of the compact bone as well as the spongy bone, but just understanding that the internal tissue of bone is going to be more spongy bone and the outer layer is going to be more of your compact bone. So, structure of the compact bone. You have these individual units, these individual bone cells, if you will. We call those osteons. Okay, this is your basic structural unit of bone tissue. They are long cylinders that act as tiny little weight-bearing pillars in your bone. Okay, and so think of these as like columns or something that run the length of your bone tissue. They're made up of a group of hollow tubes that we call lamellae, or each individual one would be a lamella. And these are filled with tiny salts and collagen fibers. These allow bones to resist torsion stress. So any sort of side-to-side or twisting sort of tension, these will help resist that. Okay, so those tubes very much by design help resist any sort of tension that could otherwise lead to a fracture or a break. You have a central canal here in the middle that runs through the middle of each of your osteons. So you can see here, this would be an individual osteon. This is your central canal here. Same thing here, another osteon here as well, right? So you can see these individual sort of cylinders that would run lengthwise along your bone tissue. And in these central canals, you basically have small little blood vessels that can bring nourishment, so any sort of nutrients that your tissue might need, and then also nerve fibers for cell signaling is also a really important thing here. So you have your blood vessels, your lymphatic vessels, your nerves, anything that needs to travel along the bone, it will do so through this central canal. And then it's surrounded by these really, really good resistant lamellae that run the length of that bone. Overall structure of spongy bone. So we covered compact bone, but on that interior portion of spongy bone, this is a little less organized. Okay, it's porous, just like a sponge. All right, that's where it gets its name. We don't have osteons here. Okay, so that's exclusively to that outer compact, smooth layer. No osteons here, but we do have what are called trabeculae. Okay, now trabeculae are these little struts that are key for helping the bone resist stress in a variety of directions as well. You can see here that these are a little less organized, right? They're just these little struts. They kind of overlap and kind of go in every which way, and that creates a lot of resistance to stress that might be placed on the bone in any of those directions. So it's kind of like a spongy network of these trabeculae that help resist stress. And also, this is where our bone marrow is located within the spongy bone. Remember, red bone marrow is where we have blood cells created, and our yellow bone marrow is going to be a storage for fat tissue, which is a really, really good go-to high energy, low intensity energy source in your body. So it's good for storage of energy, and it's really good for the bone marrow where we create new red blood cells. That's what your spongy bone is there for. And finally, a little more of bone structure as an organ rather than as a tissue. The external surfaces of a bone are rarely smooth, right? You're going to be often seeing a ton of these distinct bone markings that correspond to how the bone and its attached muscles and ligaments will all function together. These bone markings can vary greatly, right? There are no shortage of bone markings. We're not going to get into all of the ones that exist, though I will provide some resources in case you do want to do a little deep dive about the different types of projections and surfaces, depressions, all of these things. But just know that these bone markings are always going to be there for good reason, and typically they're going to be attachment points for muscles and ligaments. Okay, the three types that we're going to cover, the very general broad types that we'll have in this class, are going to be your projections. So projections are where muscles and ligaments attach specifically. You have surfaces of bones where joints exist, right? So where two bones come together, for example. And then you have depressions and openings. This is where blood vessels and nerves can run through those bones and they can enter and exit. Okay, so projections for muscles and ligaments, surfaces where joints exist, where bones come together, and then depressions and openings for being able to nourish and innervate surrounding tissue. And that is going to do it for our part 2 discussion in concept 1, and we'll see you in part 3 to finish up the discussion in the next one.